All right.
Okay,
Thank you.
we good?
Yep.
I can hear myself. Right. Well, good evening and welcome. I have to say it's a real pleasure to be here. I've actually been doing a number of these jug visits in North America over the last 4 or 5 months now. I think this is my 6th trip to the US because I live in London. I think this is my sixth trip to the US this year so far. What I'm also really impressed by is the number of jobs on offer. That's really quite impressive, and that's been the case at a lot of these events that I've done, because we were in Austin a while ago, and there were a lot of jobs on offer in Austin as well. So it is really interesting to see that Java, despite being only 22 years old, is still something where there's a lot of opportunities. Which kind of brings me to my talk for this evening, which is JDK 9. What I'm going to be talking about here is not JDK 9 in general. I'm going to focus on Project Jigsaw. So let's have a show of hands here. So who's using JDK 8 at the moment? Right, most people are using JDK. JDK 7? Ooh, okay. 6? Anybody using anything older than 6? Okay, good. That's respect. And has anybody tested applications using JDK 9 yet, the early access builds? 1. Okay, that's also interesting. Well, I think after I've spoken to you this evening, I would certainly encourage you to test your applications with JDK 9 early access builds, because there are a number of things which are going to affect you as developers. And we'll talk about those from the point of view of modularity, because this is big changes in Java. Now, the first thing that I want to talk about is, before we get into modularity in general, let's talk about the way that the APIs that we use in Java are going to change from a structural perspective. Right, what do I mean by that? If you look at Java at the moment, you have rt.jar, big jar file, which contains all of the classes and methods that you are allowed to use to write your application code with. But the problem is that that rt.jar file contains all of the public APIs that you have available to you. But there's also a lot of APIs in there which are there to make the public APIs work. And these are APIs that right from the very beginning, right from JDK 1.0, you as developers have been told, do not use them. They haven't been documented, they haven't been publicized, they're not even properly supported. So you haven't ideally supposed to use these things. Now, if you look at the way these are divided up, you will find that there are packages. And the most obvious ones are the java.star and javax.star packages, which are the ones which are from the Java SE specification. But there are also some other public APIs that you're quite entitled to use to write your applications. They're supported, they're documented, great stuff. These fall into packages like com.sun.star, and an example of that would be there is a web server that ships as part of the JDK. It's not part of the standard, but it's part of the JDK. So if you want to write something that needs a web server, you can actually do that without using even something like Tomcat or Jetty. There's also some JDK.star packages, which are things like the ability to control the compiler programmatically. Again, not part of the Java SE standard, but part of the JDK. Then there are all these other ones, the ones you're not supposed to use. And these fall mostly into the sun.star packages. The most famous, or infamous I should say, is sun.misc unsafe. Now, personally, I really like sun.misc unsafe. There's a clue in the name, unsafe. You shouldn't be using it. So let's have a show of hands. Who here has used sun.misc unsafe in some way? Okay, one person. That's not bad actually, only one person. Well, what you will find is that a lot of people have used sun.misc unsafe, and certainly if you look at the kind of feedback on JDK 9 as it has been over the last few months, you will find that there are a lot of frameworks, there are a lot of things like app servers and various things that you use to build your applications which have used things like sun.misc unsafe. And this is going to be an issue. Compatibility has always been a concern for Java. If you look at the way that Sun developed Java and Oracle have developed it since it acquired Sun, you will find that compatibility has been something that's a big concern. And the idea is, the way that it's being described, is that if you have an application which only uses the supported APIs on version N, it should work without any changes on version N+1. Now, there have been a couple of places where that hasn't necessarily worked. So if you look at like version 1.4, JDK 1.4 introduced assertions. So assert became a reserved word and you couldn't use it as a variable name anymore. JDK 5 introduced enumerations. So enu became a reserved word, you couldn't use that as a variable name anymore. So a few things where compatibility hasn't quite worked exactly the way that it should have done. But on the whole, Java compatibility has been pretty good. Most of the time you can just take your code, you can recompile it, you can run it on a new version. You can even take old versions of your compiled code and you can run it on new versions as well. Certainly I did a talk on 20 years of Java a couple of years ago, and I found that there were even some of the applets, for those of you who can remember applets, that would run from version 1.0 on version 8. So they looked quite small because the resolution of the screen was designed to be a lot smaller, but they actually ran. Not all of them did, but some of them did. One of the other things that has been made clear in terms of the way Java is developed is the fact that the APIs can be removed. So there is this idea of being able to deprecate things, there is the idea of being able to evolve the API, not just adding things, but removing things as well. But you will have notice about this. So things will not just disappear overnight, you will get warned about it. I did some research on this, and I found that if you look at JDK 8, there are 18 interfaces, 23 classes, 64 fields, 358 methods, and 20 constructors that have been deprecated since JDK 1.1. Anybody want to guess how many of those have actually been removed? 0, correct. None of them have been removed. Until now. So things are going to change in JDK 9. Now, there are a number of incompatible changes that are happening between JDK 8 and JDK 9. If you are the average Java developer and you stick to the standard APIs and you just write, let's call it normal Java code, most of these are not going to catch you out. So you don't need to worry about them too much. But if you start stepping outside of the sort of the comfort zone of Java and you start doing more esoteric things, then some of these might catch you out. So the first thing is that a lot of the JDK APIs are going to be encapsulated. I'll talk more about this in detail as we go through, so I won't cover that now. A small number of supported APIs are actually being removed from JDK 9. When I say small, I really do mean small. There are 6 methods that are being removed. They are in the Pack 200 class and the Log Manager class. They are all property change listener, add or remove methods. So you immediately think to yourself, what are these 6 methods done that is so bad that they have to be removed at this point? I will come back to that later as to why these have been chosen for removal. They were all flagged in JDK 8, and so you've been given advance warning of these. As I say, because they're in Pack 200 and they're in Log Manager, they are property change listeners, most people won't be troubled by these. The binary structure of the JDK and the JRE is going to change. So just the file layout, there won't be a separate JRE directory, there will be only one bin directory, there will also be a conf directory, things like that. If you rely on certain files being in certain places in your application for whatever reason, then you may have to make changes to your code. The version string format is changing. So the version string format in Java before has always been rather confusing, shall we say, because you have JDK 8, but if you look at the internals of JDK 8, you'll find it's actually JDK 1.8. And you have this funny update thing, so you have JDK 8 update 40 or 50 or 60, and it's very difficult to tell which version is which and things like that. So there's a much more logical numbering scheme being used now. So you will have JDK 9, it won't be a 1.9, it'll be 9, and then there'll be a point release based on that. One other change that might catch you up, but I hope it doesn't, is that the single underscore will no longer be valid as an identifier. So you can't use it as a variable name. Hands up anybody who's used a single underscore as a variable name. Okay, now I'm hoping that the reason you've done that is in something like a lambda expression, where you had a single parameter which you were using, or you weren't using in the body of the lambda expression, and so it's logical to do that. So that is actually the reason why they're doing that, just to make it easier to do that. If you really did want to use a single underscore as a variable name, you can make some modifications to your code. You can change it to a double underscore, because that will still work. I tested it. It does actually work. And in fact, you can have as many underscores as you like as a variable name. Not one, just more than one. There are two other things that are being removed which are related to the modularity system. One is and these are really to do with class loaders. One is the endorsed standard API override mechanism, and the other is the extension mechanism. These are primarily used by things like app servers, where they need to load additional classes before they start loading the classes for your application code. Again, I'll kind of come back to that when we talk more in detail about the module system. Right, now Oracle did some research. They looked at a lot of their Java code and things like Fusion middleware and things like that, and they figured out where they had used unsupported APIs, because they were interested to see what sort of things people were using this for. Anybody want to guess what the most popular unsupported API that they were using in their own code was?
Base 64.
Very good. Base 64 encoder was the most popular one. Anybody want to guess what the second most popular one was? No. Unsafe was the second most popular, and the third most popular was Base 64 decoder. So clearly they were doing more encoding than decoding for some reason. But this was useful to understand that there were a lot of places where even Oracle were using unsupported, undocumented APIs in their code. Now what they then decided to do was to classify the internal APIs in two ways. So the first is what they call non-critical APIs. These are ones where the API is really just so specialized that it doesn't have any use outside of the JDK. They're just so internal that nobody bothers to use them in application code. The other one is where they were used for convenience. And Base 64 encoder and decoder is a good example of that. Before JDK 8, there wasn't a public API to do that. JDK 8 introduced the public API, so now you don't need to use the internal one for that. And then there's the idea of critical APIs, which are ones where the functionality provided by those APIs is just either so difficult or downright impossible to replicate without having access to the JDK source code. So you can't write the equivalent of sunmisc unsafe just using Java code. Because sunmisc unsafe allows you to get access to memory through explicit addresses, and you can't do that with Java because you have implicit pointers. Now, when this was first discussed, the idea from Oracle was that all APIs that weren't part of the public standard would be encapsulated. You would not be able to use them anymore. And a lot of people said, well, that's really a bad idea, because we know that we weren't supposed to use them, but we have. And we've done that, and if you encapsulate those APIs, it will break our code. It will break all sorts of things. A lot of the Apache software will get broken. And people are going to get very upset if they can't continue to use a lot of these packages, a lot of these frameworks, and so on. This resulted in what's called JEP 260, the JDK Enhancement Proposal number 260. And that was the idea of how to address the needs of encapsulating the private APIs without breaking lots of code. So what they said was they were going to do is they were going to encapsulate all the non-critical JDK internal APIs, so the ones that nobody really cares about. They were going to encapsulate all the critical APIs where there was a public alternative. And if you look at JDK 9, some of the things in, some of the methods in sunmisc unsafe, there's now an alternative through the idea of var handles. So that's replacing some of the functionality with a public API. That will continue in JDK 10. So the idea is in JDK 10, some misc unsafe will be encapsulated and there will be some sort of public API that you can use to do the same thing. The critical ones that couldn't be used or couldn't be replicated outside of the JDK wouldn't be encapsulated. But you would have to make it explicit that you wanted to do that. So you would actually have to turn on some command line options in order to say, actually, I really do want to use these internal APIs. So by default, they wouldn't be usable, but you can use them if you really want to. They will be deprecated in JDK 9. The idea is in JDK 10, they will actually go away completely. They also added some command line options, which we'll talk a bit more detail about later on, which allows you to say, in certain situations, these things I want to make accessible through either access to packages or through reflection. Again, we'll kind of talk more about that a little bit later on. So these are the critical APIs that you will still have access to if you really want to. So there are 6 of them, some misc unsafe being the most famous of those. There are a couple to do with signals, so if you want to intercept things like Control-C to stop somebody from stopping your JVM abruptly, you can intercept that and handle those differently. Some misc cleaner is a sort of alternative to finalization in Java, so you can do it in a slightly different way. And then there's a couple related to reflection as well. So there are 6 that you can still use if you really want to. To help you with this, there is a nice tool called JDEPS. And JDEPS will analyze a jar file and let you know if there are APIs that are being used which you shouldn't be using. And you need to be aware of so that you can add them to the list of things that you want to make available from the encapsulated APIs. So you can run that on a jar file and you do like JDEPS minus JDK internals to a jar file and it will report on anything that's being used. I would recommend, as part of your preparation to move to JDK 9, that you run this on all your jar files. Now, I'm sure that you would say, well, I know this jar file, I've written all the code, I know I'm not using some misc unsafe, so I'm good. But chances are you're using a jar file from somebody else as well. So you need to run it on that to find out if that is using any of the internal APIs. Right, let's talk about modularity and Project Jigsaw proper now. So the first thing is to understand what were the goals for Jigsaw. What were the goals for modularity in Java? And this is something that's actually become quite a contentious issue literally in the last couple of weeks, because there's been a public letter that was written by Red Hat and a group, I don't know if anybody's seen this. There was a public letter that was written by Red Hat and a group of people who were part of the, or are part of the Jigsaw expert group, who are criticizing the implementation from Oracle. They're not very happy about the way that it's been done, and they say that there's a lot of problems with it, and they really don't think that it's going to address the issues that Jigsaw really needs to address. There's also been an article that somebody wrote based on that, which kind of takes a more or takes the opposite of view and looks at it more rationally and says, well, you know, these people are OSGI people, so they're applying what they've seen with OSGI to Jigsaw, and it all gets a bit kind of confusing and a bit sort of contentious. But anyway, if we look at the goals for Jigsaw, really you can divide them into 2 groups. The first of those is to modularize the JDK itself. And this is a very good idea because having one rt.jar file, which has by now 4,500 classes in it, is very unwieldy because you've got all these classes in there, all in one big lump. It'd be much better if you could divide it up into groups, and then you could select which of those modules you need for your application. You can minimize the size of your application. You can minimize the problems that could potentially be there in terms of security. You can reduce the attack surface. You can improve performance because if you look at the way that the class path gets scanned every time you need to load a class, modularity will solve that problem. Things like maintainability become easier for the JDK itself. So there's all good reasons for modularizing the JDK. Things like the Internet of Things. reducing the size of the JRE itself and your application makes it addressable to a smaller footprint. And that's also applicable if you're dealing with things like microservices, because then you can tune your Java runtime to the specific service that you're trying to implement and have the microservice be more micro. The second set of goals that Jigsaw had are ones which, certainly in my opinion, get a little bit more debatable, a little bit more, or less useful, shall we say. And that's the idea of making application code modularized as well. Now, yeah, modularizing applications is a good idea, but is it the role of Jigsaw to do that? Certainly the developers of the Jigsaw project think that is, but when you think, well, there's also things like OSGI that have already been available for a long time, solve a lot of these problems, why not just use OSGI for application code and use Jigsaw for the actual JDK itself? So, those are things that could be discussed a lot over many beers in the pub. Let's look at module fundamentals. What is a module? Well, a module is a grouping of code. If you think about it, Java already has this concept. So a class is a grouping of methods, it's a grouping of state in a single object. Objects and classes can then be grouped together in packages. So packages group together classes which have shared functionality. Modules takes it to the next level. So you're grouping together packages that have shared functionality. The thing about modules is that it's not just about Java code. So modules, in theory, can contain other things as well. You can have native code in your module. So if you're writing something which uses JNI and you need a native library, you can put that in the module. If you need resource bundles because you want to translate messages, those go in modules. If you need property files for configuration, those can go in module files as well. So it's beyond the level of just packages, it's now adding more things above that. So what I've done is I've created a simple kind of grouping of some code. So I have called this the Azul Zoop module, and within that I've got 3 packages which are called alpha, beta, and theta, and those have classes within them. Right, so how do we create a module? Well, in order to create a module, we need to have a definition of that module. And the module definition is placed in a module.info.java file. What it looks like in its very simplest form is simply the keyword module and then the name of the module. And then, in this case, a set of empty braces. Module is a reserved keyword in this particular context. So it is a restricted keyword, which means you don't have to worry about the fact that module is no longer going to be available to you as a variable name. It's only in the context of the module.info.java file where it's a reserved keyword. And even then, it's fairly flexible, as I'll show you in a moment. So we have the name of the module, and again, this is something that's gone through a lot of discussion about how to name modules. Initially, the Jigsaw developers wanted to keep it simple, so they would have said module Zoop. But the problem with that is it then becomes easy to have overlap in terms of your namespace. I could have my Zoop module, somebody else could have their Zoop module. When you try to use them both together, how do you know which Zoop module you're going to use? So the accepted practice now for modules in Java is that you use the reverse DNS qualified way of doing things. So you have com Azul Zoop, and then you could have com foo Zoop, and then you don't get the problem of tripping over each other's namespace. So the module.info.java file goes to the top level of your directory structure. So where you have all your Java files, you put your module.info.java file. Right now, this module definition is actually not really much use. It simply defines a module, but you can't really do anything with it. Now, what you find is that modules are going to depend on other modules. We have some code in Zoop that wants to use something in the Zeta module. So you need to tell the compiler and the runtime that there is this dependency between Zoop and Zeta. To do that, you put an extra line in the braces in your modulinfo.java file. And in that case, what you do is you say it requires the com.azul.zeta module. And that way, the compiler and the runtime now know that there is this relationship, a dependency between the two modules. We can extend that. So let's now say we're going to create an app. So we'll have our com.azul app, and that's going to require com.azul-zoop. And we'll also say that it's going to require one of the JDK modules, which in this case is java.sql. There's quite a few of them. We'll talk about those a little bit later on as well. But for now, we'll assume there is an SQL module. So this starts to build a graph of the modules that we need for our application. And in fact, we can extend that, or the compiler will extend that for us, to build up a proper picture of all of the dependencies. So app depends on Zoop, Zoop depends on Zeta, app depends on Java.sql. There's also Java.base at the bottom. Now Java.base is kind of like the object of modules. All modules other than Java.base depend on Java.base. And Java.base contains things like string, it contains things like integer, it contains the class loader, the security manager, all of those fundamental classes that you need to make Java applications run go in Java.base. So there is an implicit dependency on Java.base. That means you don't have to put the requires line in your modulinfo.java file. You can if you want, but you don't have to because it's always going to be there. So we have implicit, explicit dependencies. Also, we have an extension of that because the java.sql module is going to depend on java.xml and java.logging. Which brings us to a problem, which is readability versus dependency. So we know that part of our graph shows that app depends on SQL. SQL depends on logging. Okay, that's reasonable enough. But what we can end up with is an issue like this. So we create a reference to an SQL driver, and then from that driver we have a method which says get the parent logger. That returns an instance of a logger, and then we want to log some messages. Well, that's good because SQL depends on logging, but we have a problem. We're using that logger in our app, but the app doesn't have a dependency on logging. So the compiler, because it enforces the encapsulation within the module system, will say, you don't have a dependency on logging, so I can't resolve that because you don't have visibility of the logging packages, so we can't resolve it. Now we could solve that by saying, okay, well when we compile it, we get the error and we go, right, I need to add a dependency in my app, modulinfo.java, to say I depend on java.logging. But that's kind of nasty because you then have to compile it and you have to spot where the error is, then you have to go back and make changes and so on. Not a good way of doing it. So there's a better way of doing that, which is to use implied readability. Implied readability says that in the case of the java.sql module, what we're going to do is we're going to say it requires java.logging, but we'll also add an additional keyword, which is transitive. Transitive means that anything which is public in java.logging will also be available to any module which depends on java.sql. So it effectively says anything in java.logging that's public will be visible to java.app. So when the compiler tries to compile this, it says, okay, I need to resolve logger. I've got a dependency through java.sql on java.logging. I can resolve against the public members of that module, and therefore I can find the logger and I can resolve it and I can compile it. So that gives us implied readability. Oh, question?
So one of the classic problems, in my opinion, in Java is that library writers have a tendency to decide how we're going to use their library. And what it sounds to me like is suddenly SQL has decided that they're going to pollute my namespace with their logger.
Well, only in so much as it will pollute it with not just logger, but java.util.logger. So it's qualified. So if you want to use log4j or something like that.
Right, but if I'm bringing in java.util.star,
yeah, Well, no, it's not bringing java.util.star.
No, I'm importing.
Oh, I see,
Java,
yeah.
Right, and now suddenly I've got two loggers. Essentially, I got my logger and your logger.
No, because if you import java.util.star, you're only going to get the java.util.logger.
No, but I've also got my own logger imported to my own star.
Yeah, but that would be in the namespace java.util. So it would have. So you would have something like log4j.
Any code, I don't have it fully qualified. I've just
Oh,
got
I see what
logger.
you mean. Right. Yes. Well, that would be the same as you would have now, anyway. So
Right,
you,
but I was hoping this was going to fix this.
yes. No, it's not. Unfortunately, no. Oh, and actually, what I should mention as well is there is a rule about the word. Let me go back a couple of slides here. So I forgot to mention this. There is a rule about this graph. The rule about this graph is that it must be acyclic. You cannot have cyclic dependencies between modules in your graph. So in the case of Zoop depending on zeta, that's fine, but if zeta also depended on Zoop, that would introduce a cyclic dependency and that would be wrong. Now there's no actual reason why that can't work, it's just that the designers of Jigsaw decided that they didn't want that to work. And this has again been a point of contention that people have kind of argued against. But there's a reasonable logic to this, because if you have dependency between two modules which is cyclic, you might as well say, well, they should be one module, because they're putting everything together. Right, so, right. So this leads to an implied readability graph. So now we add a couple of extra edges to our graph, because in the case of app, it has access to all of the public elements of XML and logging through the transitive requirement of Java.SQL. So that resolves the issues of implied readability, but it doesn't solve the problem of if you don't qualify exactly which logger you're going to use, then the resolution will be difficult, if not impossible. Visibility. Now, in the case of things that we have in our module, we may not want everything in the module to be accessible to modules which specify dependency on that module. So in this case, we can say, right, we only want certain packages to be exported from our module to the ones that have a dependency on it. So we say, in the case of our Zoop module, we're going to require zeta, and we're going to export alpha. Alpha will be exported to all modules that have a dependency on Zoop. We can qualify that. So we can say in the case of beta, we only want to export that to the COM Azul app. So only the app module will have access to the public elements of beta. If we had another foo module that had a dependency on Zoop, it wouldn't be able to see the public elements of beta. So that will be encapsulated to all modules other than COM Azul app. So from the point of view of visibility, alpha is visible to everybody, beta is visible to only the app module, and the theta package, public elements, are not visible at all. They are encapsulated.
Can you export to multiple namespaces, not just app, but like you like
Yes.
Azul on Star?
Yes and no.
Oh.
So yes, you can export to multiple ones, but you must have a common separated list. You cannot use a star. The Jigsaw designers do not like wildcards. They think they are bad. So you can't do export star, to star, and also you can't do can't do exports to star, and you can't do exports star. So every package that you want to export from your module has to be explicitly stated on a separate line. Now there is some logic to this, which is that if you start using a star wildcard, then you're basically saying everything gets exported, and if somebody comes along and adds another package to that module, it automatically will be exported as long as it's fits in with that wildcard. So that is a bad thing. So what you need to do is explicitly state all of them, but it can be a bit sort of, again, something that's debatable.
Does export works on the package level only, or I can export the single class?
No, it's package level, because everything in the module level works on packages only.
Can you do the opposite of exporting? Like if you're getting a transitive dependency, can you stop the dependency so it doesn't propagate up?
No. you can only say exports transitive of a package. There is more to package visibility. Package visibility gets quite involved. Now, one of the big problems, if you like, with modules in Java is reflection, because people often use reflection to access things which are not part of the public namespace. If you want everything in your module to be accessible through reflection, then you can use the open modifier. So you can say open module, Azul Zoop, and then everything, all of the packages in that module will be accessible through reflection from other modules. We can make that a bit more complicated, and we can say that rather than making everything visible for reflection, what we can do is we can say, let's only make the theta module, theta package, accessible through reflection. So in that case, we use opens Azul theta. Until a couple of months ago, that was a really bizarre export private Azul theta, which was really kind of weird. The idea of export private. This is like public private. But anyway, they've changed it to opens now, so it's a little bit clearer in that sense. So now, in the case of theta, you can't import it, but you can access it through reflection. So it's not exported, but it is accessible through reflection. Restricted keywords. So I thought to myself, okay, so restricted keywords mean that the keyword can be used as a name, as long as it's not used in a particular position in the definition of the modular-info.java file. So I thought to myself, could I call my module module? Yes, I can. And then I thought to myself, well, could I have a package called export requires? So yes, I can requires. And could I have a package called exports? Yes, I can. So I can exports to. Yes, I can do that as well. And then I can also opens. So I can have module, requires, exports to, opens. That is completely valid JDK 9 code. I tested it, it works, compiled.
Hooray! Say exports module to open.
Yes, you could mix and match. I haven't actually thought about that. You could make it really confusing if you wanted to. Yeah, you could mix and match those things. Yeah, so you could export to requires module or something like that. No, that wouldn't work, would it? No, it would be exports module to requires or something like that. Yes, you could do all of those things.
Is this a feature or what?
I believe it's a feature. Right. So accessibility. Now, accessibility is what do we need to do in order for one module to access the public elements of another module? And there's two things that need to be satisfied for that to happen. The first is that we need to specify dependency from one module to the other module. But the other thing is that module also needs to make sure that it exports whichever module, or whichever package we need the public elements of. So there's two different things that need to be specified. So we have the idea of it both being exported and also having a dependency on that. Now what this means is that from a language point of view, there is a bit of a change for Java. It's a slightly subtle change, but it's quite significant. Now we're used to 4 levels of control over accessibility. So we all understand public, protected, package, and private. We know what they mean. In JDK 9 that changes a bit, because public now doesn't really mean public in the way that it used to. Because public can now mean public to everyone. So the public elements of a package can be public to everyone, because they're exported and you have a dependency. They can be public but only to specific modules, where you say export that module to that module. And they can be public but only within a module. So if you don't export a package, then the public elements of that package can only be used within the packages of that module. So this means that public doesn't necessarily mean accessible in the way that we're used to it. So that has changed. It is a fairly fundamental change in terms of Java. Right. dependencies in JDK 8. Now this is where things get a little bit complicated, and this is why Jigsaw has taken really quite a long time to actually complete. 4,500 classes make up R2.jar, and if you go right back to JDK 1.0, you will find there are about 200 classes. So we've added some 4,300 classes over 22 years. The way that that's happened is that as new classes have been developed, the developers have gone, right, well I've got this class here, I can use that, and I'll use it to develop the new class. That's the way we do things. And then as time goes on, we just use all the other classes that are available. And that's a real problem, because you end up with trying to separate it out into a number of discrete modules. You find that there are these weird relationships between different parts of the system, which make that very difficult to do. So this is the kind of first attempt that they had of separating things up in JDK 8. So it's sort of like an eye chart to not test your eyes, but to show you the complexity of it. What we can do though is we can kind of zoom in on a couple of bits of this. So one of the bits here shows that at the top we've got the JAX-WS module, and that's the web services, XML web services module. Okay. And at the bottom we've got the beans module, so Java beans. And there is an edge in that graph which goes from JAX-WS to beans, which means that JAX-WS depends on beans. Okay, that seems fairly logical. There's some use of beans by JAX-WS. Okay, fair enough. Let's zoom in on another part of the diagram. This time we'll see that on the right-hand side we've got the beans module, and on the left-hand side we've got the desktop module. And there is an edge in our graph that goes from desktop to beans. Again, quite logical, desktop uses some beans, so that's fine, I understand that. But hang on, there's an edge from beans to desktop. That's problematic because it means if you want to use JAX-WS, you have a dependency on beans. Beans has a dependency on desktop, which means in order to use JAX-WS, you need desktop. How is that possible? This is where things get kind of complicated. And this comes back to why we need to remove 6 methods from 2 classes. So I dug into this because it was one of those things that's kind of intriguing. So why does beans have a dependency on desktop? And if you look at the code, what you find is that when the beans, there's a thing called a bean descriptor as part of the beans package. And I can only assume that when they created this, they gave the task to an intern. The reason they must have given it to an intern, because if you look at a bean descriptor, what you find is that there is a string, which is the name of the bean. Very logical. There's a string, which is a description of the bean. Very logical. But then, obviously, the intern said, oh, I'm an intern, I want to prove how good I am. I will make the bean descriptor even better. What can I add to the bean descriptor to make it better? I know, I'll add an icon. We'll have an icon associated with the bean. Now, an icon is a graphic representation. In order to render that, we need Java 2D. Java 2D is in the desktop package, so we need a dependency between the beans and the desktop package. So things like that became very difficult to separate everything out. And you could potentially end up in a situation where just using one module means you need all the modules from everything in Java, which kind of defeats the whole idea of Jigsaw. So removing those 6 methods actually allows them to separate things out in a more logical way. Which kind of leads to this, which is slide 1 of 2 of the modules that we have in JDK 8. I won't go through all of these because they're fairly sort of obvious in most of them. There's things like Java.SQL, there's XML, there's logging, scripting management, so on. But there's also at the top there's one called Java.SE, which is in blue. Java.SE is a meta module. So a meta module doesn't contain any packages itself, it just contains references to other modules. The idea being that if you want all of Java.SE, you can specify a dependency on the Java.SE module, and then you get everything which is Java.SE through the transitive dependencies. In terms of the arrows that I've drawn here, anything that's in a yellow or orange arrow, that means there is a transitive dependency, so you can access the elements of whatever the arrow points to through the one that it comes from. The ones in blue and dotted means that it isn't a transitive dependency, so you don't get the access to the one elements of those modules. The second page is the rest of the modules, and we get this rather bizarrely named java.se.ee, because over time, a number of the things which make up Java Enterprise have gradually kind of sneaked into the JDK. So we've got things like naming, we've got things like transaction support, we've got things like, binding, and stuff like that, that make up part of Java EE really, and shouldn't, strictly speaking, be part of the JDK. They've just kind of snuck in. Some of these things are actually going to get, well, the proposal is that they will get removed from JDK 10. So we'll go back to a more pure Java.se JDK rather than having EE pollution in there as well. Right, how do we use modules? One of the goals of the module system was to eliminate class path hell. How do we eliminate class path hell? It's very simple. We rename it module path. So we end up with, if we want to use modules and we want to compile using modules, we say javac minus the module path, and we specify a list of directories separated by a colon, which contain our modules. So you're thinking, okay, I don't see a lot of advantage there other than it's called module path rather than class path. Bear with me, it does get better. So if we want to use that to compile code, we'll do this type of thing. So we'll say javac minus module path, and where the modules are minus D where for the modules. The particular module info.java file we want to compile, and then the name of a Java file which we are going to compile as well. So they will get compiled into class files, which can then be used in whatever way we want to use them. So again, still not seeing any great advantage here. If we want to execute code, we can again use the module path. The Java engineering people have kind of got very confused with the minus options and the minus options, because they've tried to implement all the minus options with the longer versions. So now we have Java minus P, because minus module path can also be abbreviated to minus P, whereas minus class path can be abbreviated to minus CP. But they've also introduced, to make life just a little bit more interesting, that you can now also have minus class minus path, if you really want to. But anyway, so you can do Java minus P mods, which is where the module is coming, and then you can say minus M to specify which module you want to use for the execution of this code. So you're going to use the app module, and you can also then specify the main entry point in that on the command line. So that will then allow you to run your application. How do we actually create a module? So we talked about having a modulinfo.class file created from modulinfo.java file. To create a module, we put everything into a jar file. Jar file then becomes a module. We can do that using the jar command. So now we have jar minus create minus file equals mylib app.jar, which is where it's going to go. Minus main class equals Azul app main, and minus c mods, which is where it's going to come from, and dot, which is the directory where we are at the moment. That will create a jar file, which is a modular jar file, because it has a modulinfo.class file in it. Modulinfo.class file has to go at the top level, so you can only have one modulinfo.class file per jar file, which means only one module in jar file. You can then use the new command line options on the jar command to say jar minus print minus module minus descriptor, or just minus D, which is a whole lot easier, and then you can get the list of the modules that are contained in that particular jar file. So in this case, we've got our app, which requires Azul Zoop, which requires Zeta, requires base, mandated, requires Java.sql, and requires, has a main entry point, which is the main class. If you then want to execute that, That's quite easy. We can then just say Java minus P, mylibs, mods, and minus M, because that's the module. And because the jar file now contains the main class, we don't have to specify that on the command line, and that becomes easier.
Question. So I guess the mandate word now will be restricted word, right?
No, no, that's just part of the what gets printed.
Yeah.
That one, yeah. Yeah, so that's not actually the modular.info.java file, that's what gets printed by the jar command. So mandated is just, it's saying it's mandated, so it doesn't actually mean anything in terms of the actual.
So if you put it, it's just going to ignore it.
Yeah.
And take it like a normal string.
Yeah.
So is this mutually exclusive with minus CP?
No. We'll get to that.
Oh,
Oh,
so we-
definitely not. No.
Oh, okay.
No, you can mix and match.
Even more fun.
Right. Linking. Oh, sorry.
When you say you can only have one module,
Yes.
one info, so you're saying that we can't ever produce any single jar ups anymore?
No. You can only have a single module in. So the way that you can do well. Yes, is essentially the answer to that. Yeah, you can't. You would have to make it a single module if you were to do that. So you would have to put everything in one module, and then it kind of defeats the object of having of making a module. So yes, if you want to have everything in one jar file, then it becomes a single module. If you want to have multiple modules involved, then you can't have it all in one jar file. So yeah, that is the answer to that one. Linking. This is the idea of creating a runtime which is specific to your application, so that you can shrink the size of the runtime by not including any of the modules you don't need. So in this case, what we're doing is we're using the JLink command, and now we're specifying that the module path is where we want to get our modules from, and we're going to add some modules, in this case just one, java.base, and we're going to create an output into my image, which is a directory. That will then copy all of the bits of the JDK that are required, so like the job command, the library directory, the conf directory, and so on, into that directory, but only with the modules that you need for what you've specified here. So in this case, it would be the java.base module. And if you use the Java command in that directory, and you say ---- list modules, what you will see is java.base. That's the only module that's there. If we do that for a more realistic application, the application we've already kind of talked about, what we do here is we say we want to create a runtime for our application. And in this case, when we list that out, because the dependencies are all analyzed by the compiler, it will say, you need java.base, you need java.logging, you need java.sql, you need java.xml, app, zoom, zeta. All those modules go in there. Now, the observant amongst you might be noticing there's a little bit of extra information in there, which is at 9.0, at 1.0. And you may be getting excited. You may be thinking to yourself, oh, look, we have versioning. No, do not get excited. Versioning is not for you, no. This is only for your information. It's not actually used by Jigsaw at all. And in fact, I put a quote here from the documentation. It says, it is not a goal of the module system to solve the version selection problem. There's been a lot of debate about versioning in the module system because the Jigsaw designers really don't like the idea of versioning. And it got to the point where they actually said, because people were saying, oh, well, what we'll do is we'll actually we'll include a number in the name of the jar file. So we'll have zoop-1.0. So the Jigsaw designers went, oh, we're wise to that. Whenever you do that, we'll strip the number off at the end, which is a really bad idea because if you look at things like Maven Central, you'll find there's an awful lot of jar files which have names which include numbers, which are not versions. They're actually part of the name of the package that's being created. So they've had to backtrack on that. And so they now will allow you to have a number at the end of your module name.
I'm sorry.
So they did solve the version selection problem for the JDK, just not for the developers.
No. There is no versioning at all. So all they do is they just record a version number in there. It's not used for anything. So it's not used to resolve different versions of the same module.
But my understanding is that you can have a specific version of your, a class for JDK 8 or JDK 7 or JDK 9 in your module that's tailored to run on a specific JDK runtime environment.
Yes, but that doesn't really solve the versioning problem. It just says that you've got a version specific to that version of the JDK. It doesn't allow you to have multiple versions of the same module and then be able to resolve against those.
Especially what, like, a lot of the things that you're mentioning sound a lot like what you get when you are building your app with Gradle. Like if you have a Gradle build system and you're doing like an Android or Java, pure Java project, you already are working with modules, with have resource, GNI and all that. But you do get versioning for libraries that you're getting and stuff. So what is the advantage of going this route instead of going with the already existing ways of building? Apart from getting like smaller footprint for the Java JDK, apart from that, what's the benefit?
It is debatable. And that's why I say, if you look at the two goals that the Jigsaw project had, one is to modularize the JDK itself, which is a good goal, makes a lot of sense. But then trying to modularize applications in the same way on top of that is where things get difficult. Because as you say, there are other ways that people have already created of doing that. OSGI, like you say, Gradle, there are ways, build systems that do that already. So does it really make sense to have modules in your application? Yeah, it could be debatable about that. But wait for the next bit of the presentation and then we'll kind of come back to that. Right, so application migration. This is where things get, well, interesting, even more interesting. So here's what we see in a typical JDK 8 application at the moment. So at the bottom we've got our monolithic JDK with our rt.jar file. Then we have a bunch of jar files which are our third-party jar files, our frameworks, all the things that we haven't written ourselves. And then at the top we've got the jar files that we create for our application that we're developing. Great, all jar files. And realistically everything above the JDK is the class path. So all of those jar files go on the class path, and that's how the runtime and the compiler identify where to find the things that it needs. Okay. How do we then move that to JDK 9, where at the JDK level we have modules? So we're dealing with modules at the bottom, and everything above that is jar files. So what we really want to be able to do is take an application and run it on JDK 9. Without making any changes, because that would be the ideal situation. We don't want to change anything, we just want to run our application on JDK 9, don't have to go through all this process creating modules and stuff like that. How do we do that? Well, the answer is what's called the unnamed module, the module that has no name. Anything which is on the class path is part of the unnamed module. And so the way that works is that the unnamed module will have dependency on all of the modules in the JDK. So it basically works the same as it does at the moment. So you can take your application, you can leave everything on the class path, and you can run your application without making any changes. So as long as you haven't done anything where you've used an encapsulated API, you haven't used any of the other incompatible changes between 8 and 9, then that will work. So leave everything on the class path, run it with the JDK, and it will run in exactly the same way. So there's no problems with backwards compatibility. Tricky bit comes when you want to start modularizing your application. So let's simplify things a bit. And this time what we'll do is we'll say, okay, let's limit the number of jar files we've got. So we'll have 3 third-party jar files in the middle. We've got libgl, gluegen, and joggle. And then we've got an app jar that we created and a libjar that we created. Okay. So, as I say, leave everything on the class path, it works without any problem. If we run that application with the class path, we see our class path held, because we have to have everything on the class path and tell it where it goes. Now, I know that the engineers at, I think it was actually Oracle, discovered the wildcard and they allowed you to use it in the class path, so you could actually just say, lib/star.jar, and that would work. So let's say we now want to modularize our application code. So we convert our app.jar and our lib.jar into modules. We add a modulinfo.java file, we compile it, and we get our modulinfo.class file. So this is all good. So now what we'll do is we'll put our modules on the module path. Great. That's a bit of a problem though, because we leave our third-party jar files, which are still jar files, they're not modules, we leave those on the class path. They're part of the unnamed module. The problem is you can't specify dependency on the unnamed module. So in the case of our modulinfo.java file, we need to require libgl, we need to require libjobble, we need to require libglujin, and we can't specify dependency on that. How do we get around that? The answer is automatic modules. So what we need to do is we need to convert the jar files in the middle into modules. Now, yeah, sure, we could ask the developer to create a module for us, we could take the module of the jar file, we could separate it out into all the files, we could add a modulinfo.java file, compile it, repackage it, and create a module. And that's really kind of complicated. So the way to do that is, first of all, have a look at what the dependencies are. So analyze the dependencies and go, okay, these are what we need. And then we'll create automatic modules. So an automatic module is where you take a jar file without changing it, and you move it from the class path to the module path. When the virtual machine encounters that, it will say, there is no modulinfo.class file, so it's not a true module. We will treat that as an automatic module. So we'll say, it's a module. The name of the module is going to be the same as the jar file. In terms of what it exports, it will export everything that's public. And in terms of its dependencies, it will depend on everything else on the module path. That way we can alleviate all the problems, and we can just take our jar files from the class path and move them to the module path without having to change anything. So all of that will work quite happily. We get a slightly different dependency graph. So everything now, I think I've got all the arrows in there. Can anybody spot a problem with that dependency graph? Cyclic, yes, it has cyclic dependencies in it. And I told you that it had to be an acyclic dependency graph. So when I saw this, I thought to myself, there's a bit of a problem there. So I kind of dug into the documentation, and I found this little bit which says, yes, we know that there will be cyclic dependencies created by this. Don't worry about it, we'll fix them in the JDK. So just ignore them. But it does, again, lead to that discussion about, well, if you're going to do that for this situation, why not have cyclic dependencies supported in the graph anyway? But that does solve that problem. So you can now move jar files from the class path to the module path. You can mix and match. You can have them in whatever way, shape, and form you want. And then that simplifies your class path hell. So you move away from that into your module path, and you say, okay, everything's on the module path. All of the dependency graph is created by the compiler, used by the virtual machine, and everything gets satisfied nicely. Right, so just for a few minutes, let's talk about some of the advanced details of Project Jigsaw.
Could you go back for a minute?
Oh.
Don't you have to specify a class on your Java, or is there a default class in the module MyApp?
Well, we would have, so long as it's the same MyApp that we generated the jar file, the module for previously, we put a main class in that, so it would be in the module. Yeah. If you didn't, then yes, you would have to specify the main explicitly, but I'll assume that in that case, it's in the module. Now, one of the things that was originally proposed for the module system a long, long time ago, in a galaxy far, far away, was the idea of not using jar files, but using a thing called a JMod, which was going to be a new file structure specifically for modules. And although we use jar files to make life even more confusing, we use jar files for our own modules. The modules of the JDK are actually in JMod files. So if you look in the module directory in the JDK, you won't find jar files, you'll find JMod files. JMod files are a kind of an extension of being able to add more things to the module. So they do include the ability to have native code. They do include the ability to have property files, configuration files, those sorts of things. And they're based at the moment on the zip file format. I need to check whether that's actually been confirmed yet. There's also a JMod command, so if you really do want to create your own JMod, then you can. So there's the ability to create, list, describe various options and things like that, which I won't go into. One extra thing that you can have is you can have the operating system name and version associated with a JMod file. So if you have got native code, then the system can check that the native code matches the platform that you're running on it, so you don't get problems with that. Class loaders. So in JDK 8 and earlier, or actually since JDK 1.2, there have been 3 class loaders that get used for your application code by default. So the first is called the Bootstrap class loader, and it has a thing called the Bootstrap class path, so you can override where the JDK classes come from. So that loads all of the JDK classes. Then there's these things called the extension class loader, and which allows you to have things like app servers that load in lots of extra classes that they need for the app server before it loads your application code. And then you've got the application class loader, which loads everything off your class path. So that kind of has 3 different class loaders that you've got. In JDK 9, there are still 3 class loaders, but they change a bit. So the first one is still called the Bootstrap class loader, but now there is no way to change the Bootstrap class path because there isn't a class path in the sense that you had before. So there's still Bootstrap class loader that loads some of the internal classes, but not all. There's a second class loader, which is the platform class loader, and that loads the remainder of the classes which are the internal ones. Now, the reason that they're split into 2 is so that the Bootstrap class loader will load things with full security privileges. But obviously that could be a potential security problem if you give every class in the JDK access to all security privileges. So the idea is by separating it into 2 class loaders, the platform class loader can now load some of those classes with reduced security privileges, the idea of tightening up the security model. And then you've got the application class loader, which loads both things off the class path and the module path. Services. This is something that's been around since JDK 6, so it needs to be supported in the module system. So if we look at the java.sql module, you'll find that SQL requires a driver that's specific to the database that you're using. So we all know, how we use that type of thing, like class.forename and things like that. So what we do here is we say that in addition to requiring certain packages and exporting other packages, it also uses java.sql.driver. And then if you look at a module such as the MySQL JDBC module, that works in conjunction with the SQL module, and it says it provides the java.sql driver with an implementation, which is com.mysql.jdbc.driver. So it's that link between the SQL module and the MySQL module to say this is the implementation that will be used with the interface in that module. The big kill switch. So this was fairly recent change that was introduced in Jigsaw. And this was really in response to people's concern over how much code was going to get broken by JDK 9, even with the ability to use some of the encapsulated APIs that were supposed to go away. So what they said was they were going to add a feature to that, which is he's dead, Jim. And we're back. Yes, so there was a certain amount of code, or quite a lot of code that was going to get broken even with the ability to access some of the encapsulated APIs. So there's now a command line switch that you can use, which is ---- permit illegal access. And what that basically does is turn off Jigsaw. So it says turn off all of the encapsulation from the class path modules, so anything that's on the class path, to the JDK APIs. So you can still use reflection, you can still use any of the packages, any of the classes that are in the JDK without having to worry about encapsulation getting in your way. So it overrides encapsulation only from the unnamed module, so only from the class path, and allows you unlimited reflective access to the things that you want. Warning messages will be provided. So if you do try and access something which you're not supposed to use, you'll get a warning message sent to the error output. This is actually useful not so much from the point of view of just simply turning everything off and letting your application run. It's more about understanding how to tune the command line options to make your application run correctly, because there are these two add exports and add opens which allow you to specify certain parts which are accessible either through reflection or through imports to the encapsulated APIs. So that's a good way of kind of figuring out which things to add to those. Last book.
So question, so if you technically want to have the exact same thing as you get in JDK, putting it in the unnamed module will not be enough, because then you will still have the restriction of the reflections.
Yes.
So if you really want to
Yes.
get the same experience, you need
Yes.
to have unnamed clause.
Exactly. So leave everything on the class. If you really don't like the idea of modularity, you don't want to have anything to do with Jigsaw, leave everything on the class path and turn on -- permit illegal access. And that will make JDK 9 look very much like JDK 8. This particular command line switch is going away in JDK 10, so they say. Whether that will continue, they might actually go, oh, actually, well, people really like this, so we'll leave it in another release. But they're saying that it will go away after JDK 9. Last thing to talk about is the idea of incubator modules, because this was something, again, that was introduced not that long ago, with the idea of how modules could be used in the future to help develop the API for Java. One of the difficult things about developing an API is how to get it right first time, especially with something like Java, because if you want to add a new API, the designers come along and they go, well, okay, we think it needs to be like this. They create it, they put it into Java, and then people go, well, you know what, we don't like the logging API. There's a better way of doing it. It's called log4j, or one of the other alternatives. But you're stuck with the way that it's been defined, because it's now part of the standard, it's part of the distribution. So the idea of incubator modules is to say, okay, let's take logging as an example. If we didn't have logging in Java, we could say, right, let's add logging. So we'll create an incubator module for logging, which will look just like Java.util logging. We'll give that to people, and they can try it out as an incubator module. So it's not part of the standard, ships with part of the JDK, so you can try it. People go, we really don't like this. It doesn't work the way we want it to. It doesn't do what we want it to do. So then you can go, okay, well, we'll change it. Create a new incubator module that looks just like log4j, and then people go, oh yeah, okay, that works, that's much better, it does what we want it to do. Then you take that incubator module and you bring it into the standard once it's been tested and people actually like the way that it works. So at the moment there's only one of those incubator modules, which is for HTTP 2. Yeah, so just to summarize, a few final thoughts on this. Modularization is a big change for Java. So the fact that so many things are changing underneath does mean that although it's not a language change, although it's not changes in terms of the functionality of the libraries, the way that things are going to change in terms of encapsulation, structure of the APIs and so on, is a big change for Java. There are some potentially disruptive changes that may affect backwards compatibility. As I say, if you just use Java in its kind of like most pure sense, probably not going to be affected by that, but there are some things that might catch you out. And developing modular code using Jigsaw will take some learning. You can ignore modules if you want by using the permit legal access, leaving everything on the class path, then you can continue the way that you have been before. So it is possible to go, I'm really not interested in modules, I'll just ignore them. Just briefly mention Zulu Java because that's what we do at Azul. Zulu Java is our binary distribution of the OpenJDK. So we take OpenJDK source code, we compile it into a binary, we run the TCK on it to confirm that it does meet the standard of the Java SE. We also check that all of the source files that we've used are correct open source files, and we then make that available as a binary distribution. We provide that for free. If you want support, we are very happy to talk to you about a support contract. It's a Red Hat model approach, and we support earlier versions. So if you do want to use JDK 6, 7, or 8, then we support those. We backport fixes that we get from Oracle to JDK 7, JDK 6, and we also upstream those into the OpenJDK. So when we've done the porting of the fix, we then put it back into the OpenJDK source code. It's available for free, like I say, get it from zulu.org. Further information, OpenJDK, Java.net. Java.net is going away soon, so I'm not quite sure where that's going to go now, but OpenJDK, Java.net. There's also the JEPs, there's Jigsaw has its own project page, and jcp.org has the standard specifications for both Jigsaw and Java SE 9. That's it. So, another question, here we go.
Could you clarify a little bit about reflection into your own module? Does that have to be enabled?
Yes, because it will be encapsulated, your own modules will be encapsulated from reflection. So if you want reflection accessibility, you will have to explicitly state that you have opened that particular package for reflection or the whole module using the keyword. So yes, you have to, even with your own modules, explicitly state that.
I'm a little confused about goal number 2 in footprints. Do you use Jigsaw to reduce the footprint of the JDK you're installing, or the JRE, or your application? Which footprint are you talking about?
So the footprint I'm talking about is because the distinction between the JDK and the JRE is really kind of going away. So what we're talking about is using JLink to create a specific runtime for your application, which means that you get the subset of the JDK modules which are required for your application. So in the case of my example, we would have java.base, java.sql, java.xml, java.log. Those are the only 4 modules that it needed. So you would only have those of the JDK modules. You'd have the modules you need for your application and a Java runtime. So you can actually ship that as a contained unit. And so that's quite useful for things like microservices, because you can reduce the size of the runtime that you're deploying in your container.
Okay, so let's use a microservice as an example. If you're using Jigsaw for a microservice, do you still have to install the JRE or the JDK on the target machine?
No, because you can have you build your runtime with JLink. So
Okay.
you don't. But remember, that's only for that particular application.
I see.
So you only run your application using that runtime. Yeah.
Oh, okay, interesting.
So functions as a service have kind of evolved out of containers as a service, and I was curious, obviously the footprint size reduction seem to support that.
Mhm.
Is there a latency measurable difference between a J-linked application and a JRE?
No, because it's exactly the same. I mean, what you've got is a file system structure which contains a bin directory that has a Java executable, which is the JVM, and then you have the modules which are required by your application. So you're using exactly the same Java runtime. You're just packaging it as a unit with just the modules that you need for that application.
So the only latency, startup latency difference would be the class path scanning.
Yes, but if you're using modules, there is no class path. There is no class
So
path.
module path.
Yeah. But again, you see, that's one of the advantages that you're not scanning the module path because the dependency graph is built up. So the compiler generates the dependency graph, which means that the JVM has that dependency graph and understands where things are. So there's no scanning on the class path to find a class. It knows where they are in the module system. So it's got that graph to use rather than a long class path. Does that make sense?
So with respect to bytecode manipulation libraries, what is the impact if somebody does not open the module? Does that mean you can't do any bytecode manipulation at all? Or?
No, because so you're looking at sort of slightly different levels. So bytecode manipulation is at the class level. So classes are part of packages, packages are part of modules. So from a bytecode manipulation point of view, you can still do that. But it's how you would access the classes within that would be defined by the module system. So it's really looking at it from a different level. But the bytecodes are still the same in the classes. The classes are exactly the same structure. So if you're manipulating bytecodes in there, then you can do that. Sorry, I might have just misunderstood your question. Do you mean the
I have
runtime bytecode manipulation?
Right, runtime where actually we base a class or something like that.
Yeah, there's, if I remember right, yeah, there has been some discussion about that, and it does break that idea. It doesn't work in the same way that it did. There's no support for dynamic capabilities in this.
So doesn't that break a lot of Java-based runtimes for
Yes.
scripting?
Yes. This is why I say you should test your applications, because yeah, some of this dynamic ability to change things at runtime. If you're just doing it within the structure of you've defined your module system, then that's okay. But if you're trying to do things where you're trying to do manipulating bytecodes, which changes the accessibility or that changes the what's accessible, then that's not going to work in the same way that it did in JDK 8. Yeah.
So did they just put JRebel out of business?
Well, I know they're talking. Yeah, JRebel. Last time I spoke to JRebel, they didn't seem too upset. But yeah, I mean, there's definitely stuff going on there. Yeah, I know they are talking to the Jigsaw people.
And that unpopular thing called Spring.
Yeah, yes, yeah, exactly, yeah.
So what's a migration path for an enterprise application, a complex enterprise application that runs in a container or app server or something like that, consists of several modules, interdependencies, brings in a whole bunch of libraries? I mean, would you want to turn off all the JDK 9 features just to be able to run on the JDK, and then slowly over time kind of add modules, to decompose the application? Like, what are your thoughts on the path there?
That's exactly the way I would say that it's going to go, is that people will leave everything on the class path, and first thing is you'll do is you'll try running it with everything on the class path and see if it works. If it doesn't, then you turn on permit illegal access, so that you get the ability to do reflection into the JDK classes. And then you use the set of warning messages you get from that to figure out what you need to do to change the application to make it migrate to JDK 9 and the module system. So that's kind of like the simplest migration path before you start trying to change your own code into modules.
I'm sorry. Earlier I got the impression that if you don't turn on illegal access, all reflection is blocked.
All reflection from the unnamed module to the JDK libraries.
Regular reflection of within your module.
Oh, no, that still works. Yeah, reflection as a thing is not going away. It's only the ability to use reflection to access modules that you depend on, because encapsulation prevents reflection where it's not allowed. That's the broken way. But if you have a module, encapsulation means that by default you won't be able to access things reflectively. So you have to explicitly make reflection accessible by either opening the entire module or by specifying that certain packages are open to reflection. But within a module, you can still use reflection because that isn't encapsulated. It's only an encapsulation outside the module. But within a module, you still have the ability to do reflection in exactly the same way you did before. There's no restriction on that. It's between modules that the reflection becomes an issue.
Is there a performance cost to opening up modules?
No, it's actually less than using the class path. So it's better for performance than using the class path.
Question. So you say that you cannot change or load things dynamically. So if I have let's say the SQL module that you show, right?
Yeah.
That says uses these, right? can I change the module that has that?
Yeah, so you need to be a little bit careful about that. So I'm not saying you can't, there's no dynamic support. So things that you can do in terms of like SQL, that still will work. So you can select which driver you want to use. What I'm talking about is what you were saying about bytecode, dynamic bytecode generation and doing some of those like really kind of esoteric things with generating classes at runtime and then trying to load those. That becomes problematic.
So as long as you have the module already pre-compiled,
Yes.
those can be
Yes.
put
Yes,
on
yes,
and
yes.
off.
Yeah.
So you can technically have just everything built as small modules and then swap them in and out as you need, depending on what you're.
If you use services, yes. So there are restrictions on what you can do with that. So you can do it with services. You can't just decide that you want to have different modules as you're running the system. There is no way of doing that within the module system. But services allow you to have the ability to do things like what we do with SQL and be able to dynamically load drivers for that. So using services is okay, but not dynamically loading modules at runtime, which again is something that people have been asking for, but it just doesn't support that.
So outside of the JDK modules, how are other modules resolved?
Through the module.
Are there module repositories?
No, through the module path.
Right. So if I say I am on the MySQL dependency or MySQL module,
Right.
how does that module file resolve locally?
On the module path.
Right. But how do they get to the module?
You still need maybe.
You seem to, yeah, maybe a Gradle or something to pull it down.
Yeah.
There's some tweak configuration.
Yeah.
Assemble meeting.
All right, folks, let's cut it off now. We got some giveaways here. So Simon, thank you for the talk. We appreciate it.